Hello everyone, today we're going to look at how to simplify algebraic fractions, and we're going to start very simple with normal fractions and then build up into some more challenging ones based on factorizing quadratics. Now to start with, I've just got the very first fraction on the left hand side, 6/8. When we simplify a fraction, we're finding a equivalent fraction which can be found by dividing the numerator and denominator by a factor of both of them. So for example, if we look at 6 divided by 8, a number that goes into both of these, a common factor, is 2. If we divide top and bottom by 2, 6 divided by 2 is 3, 8 divided by 2 is 4. That cannot be simplified anymore because the highest common factor of 3 and 4 is 1. We now come to the middle column. We're now going to incorporate some algebra, but we're going to apply the same principle. P squared q is the same as P times by q. And on the bottom, P q to the 4 is the same as P times q times q times q times q. We need to divide top and bottom here by something that's common to both. Now if we look at this, I'm actually going to underline what's common to both. We can see there's a P on the top and there's a P on the bottom. That's the only P. And there's one Q over here and one Q over here. So we can divide the top by P and one Q. And we can divide the bottom by P and one Q. And what will happen is those will cancel out. If we cancel out the P with the P and the Q with the Q, on the top we're left just with the P, and on the bottom we're left with Q times Q times Q, which is Q cubed. So P divided by Q cubed. We can't cancel that down anymore. So we bring it to the last column on the right hand side. Now this is a combination of both. We've got numbers here and we've got letters. So if we apply the same process we did before, where we write this out in letter form, we would write this as 21 A times B times C times C times C, and underneath we would have 35 A times B times C. And I'm just going to cancel out and underline what is common to both. We underline what's common. The A is cancels with this A. The B can cancel with this B, and one C can cancel with one C. Some of you may know via your rules of index laws that you could have done C cubed minus C in terms of the indices of 1, and we would have been left with C squared. But from this, we've got 21 C squared and 35A on the bottom. So our numerator would be 21 C squared and our denominator would be 35A. Now, some of you will now notice that we've cancelled out the letters, but we haven't done anything to the numbers. We can still cancel this down more because there is a number that is a common factor of 21 and 35, and that is 7. So we divide top and bottom by 7. 21 divided by 7 is equal to 3. So on the top, our numerator is 3C squared, and on the bottom, 35 divided by 7 is 5A. And what we've done there is very simply cancelled down and simplified that algebraic fraction all the way to the bottom. 3C squared divided by 5A. Now, things change a little bit, and we can make this a little bit more challenging when we incorporate and bring in quadratics. Now, we've seen previously that when you have a quadratic, you are able to make things multiply together via the method of factorizing. And that's exactly what we're going to be doing with regard to these quadratics. We're first going to factorize and then simplify down afterwards. Look at the top quadratic over here. This is x squared plus 4x, and normally there'd be a value here of plus 0. We would need two values, that times to make 0 and add to make 4. The only combination of that is 0 and 4. But some of you may notice that that's simply just taking out a factor of x. From the top, we get x brackets x plus 4. That's the top of our function. The bottom, we need two values that multiply to make 8. So the product here is 8. Our combination is 1 and 8, or 2 and 4. We're looking for the combination that adds to make 6. 1 and 8 doesn't, 2 and 4 does. So we can write that as x plus 2 and x plus 4. And we notice from that we can now cancel out whatever is common, and the common factors here are the x plus 4s. They cancel out, leaving us with x divided by x plus 2. So that has been factorized and then simplified, and that's the process. Generally, when you have a question like this, something will always cancel out. So let's bring it to the question on the right hand side. We've now got some negatives in this. So if we look at the top one, x squared plus 7x minus 30, the product for this is minus 30. We need two numbers that multiply to make minus 30 and add to make 7. That could be minus 30 and 1, or 30 and minus 1, 15 and minus 2, or 2 and minus 15, 3 and minus 10, or 10 and minus 3. Now we'll notice the only combination here that adds to make 7 is this one here, 10 and minus 3. Minus 30 and 1 makes minus 29. 30 and minus 1 makes 29. 15 and minus 2 is 13. This is minus 13. This is minus 7. And this is plus 7. So our combination is going to be x squared plus 10x, or x plus 10 and x minus 3. That is our first combination. I haven't done the long-winded method, just trying to do it quickly because our focus today is about simplifying quadratics. So we now bring it to the one underneath. Two numbers that multiply to make 9. So we need two numbers that multiply to make 9 and add to make minus 6. Now, if I'm looking at the value of 9, two numbers that multiply to make 9 could either be 1 and 9, or 3 and 3. Now, neither of those add to make 6, or minus 6 in this case. 1 and 9 multiplies to make 9, but adds to make 10, and 3 add to make plus 6. We, however, need minus 6. Now, because 9 is positive, a positive number can occur when you multiply either two positives together or two negatives. So because this value here is negative, this needs to be minus 1 and minus 9, and minus 3 and minus 3. Now we have a combination that can be used, which is x minus 3 and x minus 3, which means on the bottom, our denominator for this quadratic is x minus 3 and x minus 3. Again, when we look at this, we can simplify this down by cancelling out two like terms. Two like terms I'm going to cancel out quite clearly are the x minus 3 and the x minus 3. So that leaves us with x plus 10 divided by x minus 3. Very, very common thing here sometimes, which I've seen people do, is they start cancelling out the x's. You can't do that because these are in brackets. Even over here, this x plus 2 is technically in a bracket. We can't cancel out this x with this x. So we have that scenario. What we've done here is we've factorized first using whichever method we use, and then cancelled down. Now the last one I'll give you is a more complicated quadratic, or more complicated set of quadratics, which will occur when the x squared coefficient is not equal to 1. We have over here 2x squared plus x minus 6, and we've seen for this the AC method. In this case, a is equal to 2 and c is equal to minus 6. So the AC method for this is equal to minus 12. Now we need two numbers that multiply with minus 12 and add to make plus 1. There is a 1 in that. So that could be minus 12 and 1, or 12 and minus 1. It could be 2 and minus 6, or 6 and minus 2. Or it could be 3 and minus 4, or 4 and minus 3. Now again, minus 12 and 1 adds to make minus 11. This adds to make 11. 2 and minus 6 is minus 4. This adds to make 6 minus 2 is 4. 3 and minus 4 is minus 1. 4 and minus 3 is plus 1. So that's the combination we need to use, 4 and minus 3. So I'm going to do this by the long-winded way, by the longer method, where we get 2x squared plus 4x minus 3x minus 6. And on the bottom, 4x squared minus 9. Now you'll notice there is no x squared term in the middle for that. So if we have that, actually a in this case is 4 and c is minus 9. So AC in this case is equal to minus 36. Now for this we need two numbers that multiply to make minus 36. And if we imagine in the middle of that there's actually a plus 0x minus the 9. So we need two numbers that multiply to make minus 36 and add to make 9. The only combination for that is 6 and minus 6. 6 and minus 6. So when we factorize out the bottom, we're going to have 4x squared plus 6x minus 6x minus 9. We're just going to factorize all of these in pairs to make it clear for us. Factorize the top of this one over here. 2x comes out, 2x brackets x plus 2. And if we want to get x plus 2 from over here, we need to take out a factor of minus 3, giving us x plus 2. So we have over here our x plus 2 being common to both. And on the bottom, if we factorize these in pairs, 4x squared plus 6x is again taking out a factor of 2x. And that leaves us with 2x plus 3. And then minus 6x minus 9 means we take out a factor of minus 3, gives us 2x plus 3 as well. That is our common factors. Now I'm just going to rub out or bring aside another board just to help us finish this up. So from this, to finish this up, let's bring this over here. If we now factorize out the top over here, x plus 2 is common to both. So we have x plus 2 brackets 2x minus 3. And on the bottom we have 2x plus 3 is common over there, 2x plus 3. And we're left with 2x minus 3. And now to finish that up, once again, we can factorize, or we factorize out, we can cancel out what's common. We can see that what's common is 2x minus 3, so we're left with x plus 2, right over here, x plus 2 over 2x plus 3. Now that was a much more challenging example, but it followed the same principle. We first factorized out our quadratic using our AC method, so either this one or this one. Once we'd factorized all the way down, we cancelled out what is common. That's always the case for that. I hope it's made sense. Please let me know if it hasn't.